welcome with another topic. It's very interesting, it's very enjoyable, and you will definitely have fun while listening to this because again, I would say that it could come in your MCQ type of exams if you will be facing your online exams. So let's discuss today ways of expressing what? Concentrations. Ways of expressing concentrations. Okay. So there are a number of ways. So let's find out what's all this about concentration. So concentration is basically defined as simply the amount of solid or solute in a known quantity of solution. Okay, and well, this is something interesting, and you can simply say that if we talk about concentration of a solution, so it is simply defined as amount of solute that has been dissolved in any, you can say, a known solvent, a known solvent, amount of a solvent or a solution. Okay, so what now? Concentration is again divided into two types, that is, you can say number one, a concentrated solution, and of course a dilute solution. So what is the first basic difference between these two, a concentrated solution and a dilute solution? I'll let you know just in a second. Now this is a plain water in a glass. You can see here it's plain water, right? I'm going to make it a concentrated solution with something solid, right? So I would like to take an ORS as an example of making a concentrated ORS solution. Okay, so let's see how I'll make it. So I will fill 1 spoon of that ORS, right? This, see, 1 spoonful of this ORS, and I'm going to dissolve it inside it. I'm going to dissolve it inside this solution to make a concentrated solution. I need to dissolve till all the granules get dissolved, right? Wow, it's all dissolved. So it's not at all a concentrated solution because I can't see any saturation there, right? So let's add more. So now again in the same glass, I'm going to add more of that same ORS powder, right? Everyone knows it's an oral electrolyte solution I'm making. So you can see here, now it's concentrated. You can see a little turbidity, a little cloudy, right? A little cloudy as compared to the one that is clear. This is a clear solution. You can see a clear solution and a turbid solution, right? So you can see the difference in the concentrations. There is a lot of difference between the concentration of this one that is in my right hand and this one with the spoon. It is a concentrated solution, whereas this one has nothing in it. So I'll add something into it and I will make it a dilute solution. So just to make you understand what is a concentrated solution and what is a dilute solution. Fine. Now, I'm going to make the dilute solution because as I just mentioned you that concentrated solution is, relatively something that has got, a very huge amount of dissolved solute, whereas the dilute solution, it has a very less amount of dissolved solute. So let's take the glass, see how clear and is this glass. It has no turbidity, no cloudiness. So now I am going to make a dilute solution, right, as I was just mentioning. So this is again that same ORS with a less solid as compared to the previous one. And see, this is all clear, clean water. So let's dissolve into it and see that if it's getting dissolved. We need to stir till we feel that there are no granules in it. So this is simply called a dilute solution. And you can simply see, now I will show you both the solutions. This one, that is the dilute one, and the concentrated one. You will feel the difference. Yes, there is a difference. See, this one, it is a bit more, it has changed its color and it's no more that transparent, whereas this one, it is quite transparent because, you know, the background is white, so you can't see the difference. But now from here you can easily see which one is a concentrated solution and this one is a dilute solution. Which one is a dilute solution? So this one is the concentrated solution, whereas this one is a dilute solution. So now you know what is the main difference between a concentrated and a dilute solution. This is simply showing us the concentrations, right? Now the question arises, how you will express concentration. Of course, in something, of course, there would be some units. So it is just expressed in molarity, molality, and mole fraction, right? So these are the things which we are going to discuss today. So concentrations. So according to our statement now, the concentrations are simply expressed in what? In, of course, molarity. That is this one, molarity. You can see molarity. And then molality and mole fraction. Up till now, I'm now today going to make you understand only these three. Okay, the rest of the concentration units I'm not going to discuss today. Let's discuss these first, because you will encounter these, you will face these again and again when you are dealing with the concentration calculations related to concentrations. Okay, so let's discuss molarity. It's the number of moles of solute. Number of moles of solute. Solute means the solid particles in 1 liter solution. In 1 liter. Now you will measure this amount, that what is 1 liter? 1 liter solution. So it is also called what? Molar concentration. It is also called molar concentration. Of a solution. Of a solution. It is also called molar concentration of a solution, and it is denoted by capital M. If someone asks you how you can denote molarity, you will simply say it is denoted by capital M and has a unit. It's what would be its unit? M moles per liter. This is M is molarity, right? And its unit is moles per liter. Okay, now, as I've just mentioned, there are 2 ways to express, or 3 ways to express concentration. That is molarity, molality, and of course mole fraction. So let's discuss the other term. Or no, first let's complete this one. Now, how you can calculate molarity. So to calculate molarity, to calculate molarity M of any solution, just to calculate moles of any solution, what you are going to do, how you calculate, of course, molarity M of any solution will be calculated by how the moles of solute are divided by what? By volume of solution given in a liter. By volume of solution in a liter. The same thing I've explained previously also. So this is how you can calculate this molarity very easily. So now if you're asked to calculate volume of something, how you are going to calculate the volume? So I will just give you a little small example to calculate the volume just in a second. If you are asked to calculate volume of 80 grams of sodium hydroxide solution, how you will do it? How you are going to do it? So now in our problem, volume of 80 gram of sodium hydroxide, volume of 80 grams of Na sodium hydroxide equals to what? 80 over something. Now what is that something? That is going to be, I will tell you what, the density of sodium hydroxide. As you know that, now here I can explain you know that density equals to weight upon volume, or simply volume equals to weight over density. This is something we know, that density equals to weight over volume, and if you have to calculate volume, which is our goal here, volume, then it is equals to weight over the density. So now in our problem, that is this one, volume of 80 grams of sodium hydroxide equals to 80 over 1.515, as 1.515 is equals to the density of NaOH, sodium hydroxide's density. This is sodium hydroxide's density. So now you are going to divide this 80 over by the density, right, of sodium hydroxide, and you are going to get the result, which will be equals to 52.8052 mLs. So this would be the volume of what we were asked to calculate, that is 80 grams of sodium hydroxide solution. So this would be the volume of 80 grams of sodium hydroxide solution when we will be knowing the density, and you will simply divide it, the weight by the density, and you are going to get your volume. This is, in this way you can calculate the volume easily, right? So this is one very interesting problem. They can ask you to calculate volumes also. So this is a very interesting way to calculate. A simple example to calculate how you can calculate volume of if some amount of a solute is given to you, how you will convert it, how you will divide it with the help of the density, and then you are going to get your required result. I hope you understand this example, a solved example which I have just explained it to you. Please go through such type of examples from different books, and you will be able to do as much practice as you can. You will be able to solve such type of questions easily. Let's move on. The next thing we are going to discuss today is molality. 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 What is molality? So simply, it's again a second way to unit to express concentration. It's number of moles of solid or solute in 1 kilogram of solvent. Number of moles of solid or a solute in 1 kg of the solvent in 1 kilogram of solvent. So simple and easy. And the unit for molarity would be mole per kg, mole per kilogram. So a solution that is referred to a solution of 4 mole per kilogram is said to be 4 molar or 4M solution. What? I will just explain it to you. A solution that is simply referred to a solution of 4 mole. This is, I'm just giving you an example. 4 mole per kg. What it would be? It is said to be what? 4 molar. 4 molar or simply 4M. So if you ever see something like that, that is 4 molar or 4M, you will come to know that they are talking about this thing, 4 mol per kg. This they can refer it, they are referring to actually what? 4 molar or 4M. So a solution that is referred to as a solution of 4 mole per kg is said to be 4 molar, and likewise other numbers also. If 3 molar, if you just replace 4 with the 3, it will be 3 molar, right? And molality, now how you are going to denote molality? It is denoted by a small m. Molality is denoted by a small m, right? So this is interesting. Now if you have to calculate molality, this is the equation, that is molality equals to, this would be the equation, molality m equals to moles of solute divided by mass of the solvent, in kilograms. This is how you are going to calculate, this is the way you will calculate molality, that molality m equals to moles of the solute, right? Simply divided by, this is the sign for division, oblique means division, divided by mass of the solvent in kilograms. Over here you can see kilograms. So this is how you can simply understand how you can calculate molality. I hope you have followed this also. This is very interesting and very easy, and you've been doing, having these things since you were in very early classes. The molality, first I've explained you that, what it is like, right? Then of course, if you see a 4M solution, what would be, they are referring to 4 molar or 4M. And then of course, how molality is denoted by, small m. And how you will calculate, that is equals, molality equals to moles of solute divided by mass of the solvent in kilograms. Great. Third very important unit is mole fraction. It is simply unit of a constituent's amount, that is, it is denoted by Ni, divided by total amount of constituent present in a mixture. And it is denoted by N total, T-O-T, right? So, and one thing you have to remember, that in the end result, the mole fraction simply of all components in a solution or a mixture, would equals to what? 1. This is very important. It is simply unit of constituents amount, that is denoted by Ni, divided by total amount of constituent present in a mixture, and it is denoted by N total, right? And in the end result, the mole fraction of all the components in the solution would be equals to 1, right? This thing you have to keep in mind. Now it also has a formula, and that formula would be, I can explain it to you, Xi equals to Ni over N total. Where what is Xi? What is this? I will tell you just in a second. Xi, it refers to mole fraction, whereas Ni equals to amount of constituents in a mixture, and NTOT, that is N total, equals to total amount of constituent mixture holes in a molecule. So interesting. Sorry, in moles, not in a molecule, in moles. So interesting. Okay, it is also, this mole fraction, it is also called amount fraction, right? And it simply refers number of molecules of one part divided by total number of moles in a mixture. Just remember this very important definition of mole fraction, that it simply refers numbers of molecules of one part divided by total number of moles in a mixture. So today you have learned three very interesting aspects, three very interesting parts of the concentration, that is molality, molarity, and mole fraction. I hope you like this video, and you will definitely, you have learned something today, though these things are being taught to you people since, since you were appeared in class part 1, 2, or in class 9th, 10th, first year, inter. Whenever you have come across chemistry, you might have learned all these things, but it's good to memorize, as now at my stage, I need to revise and repeat everything just to keep everything fresh in my mind. I have to, look for the fresh literature that is available. So this is all the literature that is provided to you now. It's of 2021, right? This is all of 2021 literature. Whatever is I have explained it to you, it's all 2021. Okay, the most latest of all knowledge I have provided to you. So this is nothing from the old books or something. It is something that is all on the net, and you will find it there, but in a different language, because I have just to make you understand, I have explained you in a very simple language so that you can easily understand what is mole fraction. So you can have a look again, mole fraction. If you were unable to focus, you can simply, I can again move my camera so that you can go through each and everything. Now you have this video. Those who are interested in it, they will go through these all things, because everything is unpredictable nowadays. We don't know whether you're going to give your you are going to appear in face to face, or whether in the exams, or whether you are going to appear online. I have no idea right now, so let's see what happens. So you need to be prepared for both the things, for face to face and both online, right? So I hope you will understand all this. I'm very happy and glad that I've shared all these things with you. Let's meet again with something interesting and new again. Thank you very much.